Can you see the screen? Everything's fine? Are we on the same track?
Yes, we are.
Perfecto. So, what it asking, English. What it is asking here is for us to work out PB2 plus. What we were missing is this solution. I'm looking from the sheet that you sent me prior, and now there was no solution, so we didn't know what we're shoving it into, which was interesting. That's fine.
Oh no, there is a solution written there.
Really?
Yeah, what it's written there is here.
Oh, mine was erased. Mine doesn't have the solution.
Does yours not have it written there?
Mm-mm.
That's really weird.
Doesn't matter. Let's just keep going. So, we're going to fix this right now. We agree. This is the precipitate, PBS, yeah? We've been given its KSP value of 3 times 10 to the negative 27. And it's a solution of its concentration, as you would like to say, is 0.01 moles per liter of sodium sulfate. Yep. You with me?
Yep. And I've done the balanced ionic equation.
Yep. This is not fair. It's the answers. I don't like this because I like you to make.
You said you wanted the answers.
Yes, but I like when you work for it. That's the point of chemistry. You work for your answer. Okay.
That's true.
So we've got, as you said very nicely and correctly, we've got the ionic equation of our precipitate of PBS, and the nice thing is both of the remember, we're actually going to go through this. Remember, you've got lead has a charge of 2 plus, and sulfate has a charge of sulfide. I stand correctly.
Yeah, 2 minus.
2 minus. So you do crisscross. Does that ring a bell?
Yep.
Perfect. So now, what we're going to do is we've got this situation, and it's not actually very nicely written. So I'm going to write it down here. Is that okay? Can you see my arrow?
Yeah, I can see that, yeah.
So what we're going to do is we're going to do... does this thing have a rubber? Yes, it does. Woohoo. Okay, what we're going to do is we're going to say, you can write on the sheet with me. So copy what I'm writing. You're going to say KSP equates to the precipitate. And now precipitate is PBS. So write that down. You with me?
Yeah, I'm writing it down on the sheet. Should I do it in my book instead?
Up to you. Whatever's easier for you. It's just, the answer's very basic, what they've written. I want to actually go every single step so you logically understand why we're putting things with other things. So in this situation, step 1 is being like, okay, KSP is equal to the precipitate that is made.
Yep.
Cool. So KSP value we've been given. So we're going to say, as you can see, it says 3 times 10 to the power of negative 28, which equals to PBS. So it's made to iron sulfide. So the idea
so we've already been given our, we've got our
sulfide.
Yep.
So we've got PB. That's what we're trying to find. We're trying to find the concentration of lead ions within the solution, right? So we're going to times that by 0.01. Does that make sense?
So you've got PB, and we've got timesing that by...
We don't have PB. We don't have the answer. We're finding PB, remember?
Okay. Yep. Might write this in my book so I can do it fast, and then I can actually need it for the speech. Okay.
Yep, write it in your book. It's easier. You're ready?
Times, and then you're timesing, what is it? What are you timesing by the 0.01?
You're not going to times it. We're just writing that we've got PB and we've got 0.01. Does that make sense?
Yeah.
Because the 0.01 is to do with, as you can see up here, right here, remember we said it's PBS. So we've got the answer for S. We're trying to find PB. We're trying to find iron. I mean, not iron, lead. Sorry. So in order to find lead, what we're going to do is we're going to do PB equals to this number. So 3, as you can see up here, 3 times 10 to the negative 28 divided by 0.01.
Which is our solution.
Yep. Right
so
here.
It's our case solubility constant over our solutions, and gives us our
so you've got PB, which is going to equal to your KSP value that you've been given divided by the concentration of sulfide. You can even write this in words if it makes it easy. You don't have to do, you can do words and then numbers. So you're doing PB equals to KSP divided by the concentration of sulfide.
So 3 times 10 to the negative 8 over 0.01 gives us out. What was it exactly we're finding again?
We're finding PB. We're finding lead.
Oh, how
amount of lead, the concentration of lead in the solution.
Okay, all right. Oh, after. All right, okay. So the amount that has dissolved in the lead, or
don't overcomplicate it, Heath.
Is that what it is though?
No, it isn't actually. But just don't overcomplicate. You're just finding how much you've got of lead. Because you've got a compound, right? You've got a compound. You've got lead and sulfide. You've been told how much sulfide you've got. Now you need to work out how much lead you've got.
Oh, right. Okay, so much lead in our lead sulfide we've got here in this solution. Okay,
yeah.
Cool.
Does that make sense?
Yeah, it makes sense.
Okay, cool. Okay, let's do the next one.
Okay. So next we have...
So this one's a bit more complicated because remember there's a such thing as cation and anion charges. I know I go on about them like every single lesson, but they're so important because if you get one of them wrong, it's going to be a snowball effect. All your answers after that's going to be wrong.
So we have 3.3, which equals PB.
Wait. Wait. So do you agree? We've got right here, we've got lead fluoride. Yep.
Mm-hmm.
You've got KSP, and remember it's now in sodium fluoride. Yeah.
Yep.
So in your balanced ionic equation of your precipitate, your lead fluoride, remember lead has a 2+ charge. However, fluoride has a 1- charge. So in order to have it equal or to have your
put the 2 there.
Balance, correct, you need to have a 2 because you need 2 fluoride on the left, you need 2 fluoride on the right. So you need 1 PB and 1 PB there. Does that make sense?
Yes.
Perfecto. Now, after that, we're going to do the exact same mechanism. We're going to say KSP is going to be equal to PBF2. That's step 1. We're going to be like, okay, I know that the KSP value that I got given is going to be equal to the precipitate of what I've made. So what we've made is lead fluoride.
Okay, because we know that that's our solubility for that whole. Now we need to find it just for our
for lead.
We're finding lead in there.
Lead, yeah. Because we remember. Okay, so because can you see that sodium fluoride has fluoride in it, and we've got fluoride in our precipitate. You've got lead fluoride. That means it's got a common. Does that make sense? A common ion.
Yep.
Perfect. So then, this is the tricky bit. We're going to do your KSP value. So 3.3 times 10 to the negative 8, right? Which is given right here, which is our KSP value. And I'm going to be timesing it by PB2+, which we have no idea what it is. We're trying to find it. And we're going to times it by, again, 0.01, but it's going to be squared. Remember why it's squared?
Is it because there's 2
Perfect.
on that? Yeah. On that.
So remember, if there's a number in front of your element or your compound, so in this situation it's an element, you've got fluoride, you're going to bring it up as a power. So let's say if there was 3 fluoride, right, in the equation, let's say it was 3, you would make it cubed. You would make it 0.01 cubed.
Yeah.
Does that make sense?
So we've got PB, and then we've also got times it by our 0.01, which is the solution's moles per liter.
Yep, but remember it's squared.
That's right. Why is the solution itself it's moles per liter squared when it's just the fluoride that's squared in the equation? Like, why'd you put square there in this situation?
In the 0.01.
Yeah, because it's.
Because remember, there's 2 fluorides.
But isn't that? Because the Okay, yeah, I think I get it. Yeah.
Okay, let's recap again. So, because all right, let's redo this again. Just rub it out quickly. All right, so you've got NaF, right? Do you agree? That's the solution. Yep. That's the concentration we've been given, right? Both of these, let's say, compounds have a common, which is fluoride. Do you agree?
Yeah.
Perfect. Done. But the issue is sodium fluoride it's 1. If you break this down, NaF, you'd get Na plus and F minus. There's 1 fluoride. But we've got 2 in our precipitate, right? Can you see? We've got 2.
Oh, yeah.
Does that make sense? So because we're using the solution of NaF, we have to square it because in our question, we've got 2 fluoride.
Yep.
Does that make a bit more sense, or do you want to re-go again?
No, I think I'm good. Of course. So the solution is NaF, and then we've got in that solution we've got the F.
We have a precipitate. We have an F, but
which is in that solution.
The NaF is 1F, but the PbF2 there's 2, so we need to double because there's double amount. It's like I have a liter of something, right? But I'm going to I have to make 2 of it. You're gonna have to double, right? You have to square it.
Yep.
So this situation, you've got your Ksp equals to your precipitate, which is PbF2. We're trying to find Pb. So the only thing we can do is the 0.01, which is the solution we've been given here of NaF, we need to square it.
Yep.
Perfect. So as last time, in order to make Pb, we need to make Pb the subject of the formula. So you would do, as you can see right here, you would do your Ksp divided by 0.01 squared.
Yep. Which is... Which gives you that. This 3.3 times 10 to the negative 4.
Yeah. Does that make sense?
Yes. And now I have to write these into the table.